Hey everyone, so today I will be telling you about waves, this time more in A level, but you should still check the part of the playlist on the GCSE about waves so you know the basics, okay? So for example, for the lesson today, the video that is showing now on the screen, which I'll put on the description, that's going to be the video that is going to help you, which is the introduction to waves, where it tells you that you may have mechanical or electromagnetic waves. Mechanical waves need a substance to pass through, otherwise they do not exist. Electromagnetic waves do not need a medium, therefore they can travel through vacuum. Electromagnetic waves are all the waves that you guys learned about in the electromagnetic waves, so gamma, X-rays, ultraviolet, visible light, infrared, microwaves, and radio waves. And I went from higher frequency to low frequency, smaller wavelength to longer wavelength. And all the electromagnetic waves, they move up and down or sideways, so they are kind of transverse waves. Waves can be transverse or longitudinal depending on how they move, okay? And I have actually this in here. So if you have a transverse wave, the oscillations of the wave move perpendicular to the direction of travel, so they move up and down or sideways. So the wave travels from left to right, but you can see the wave moving up and down. The oscillation, the vibration is moving up and down. In a longitudinal wave, you have the compression, so the area, the part of the wave, so you have compressions and rarefactions. The compression moves parallel to the direction of the wave, so again that's the direction of the wave from left to right, and that's the compression moving as well from left to right. So these waves are known as longitudinal. Their vibrations or oscillations are in the same direction as the wave is traveling, or in the parallel to, okay? Now, electromagnetic waves are a little bit of a special one because they are transverse waves, but in two different planes. So you have in, let's say, perpendicular in the x direction and perpendicular in the y direction, okay? So you have the electromagnetic wave and the magnetic wave, and that makes together the electromagnetic waves, okay? Now, these waves, they are showing in two planes, as I told you, right? Now, if I have waves in more than one plane, then this is known as unpolarized wave, okay? So this wave here is not polarized, sorry. And in here I have the example of me doing the polarization, which is the process of making or transforming unpolarized waves into polarized waves, and this is known as polarization. So there you go, you have the electromagnetic wave, you get a filter or a slit in one direction, so here 90 degrees up, and then only the waves that move up and down will be able to pass through. And then I have another one that is 90 degrees from the first one. This only allows the waves that move sideways, so left and right per se, or in the x direction. But these waves are already polarized here in the first slit, so they are not going to pass through, and no wave comes out of the second slit, okay? So if I want to polarize unpolarized waves, this is known as polarization. Any wave, just like the electromagnetic waves, or this one, for example, the from the sun or from the light bulb, a wave that is vibrating, or the oscillations, sorry, they are more than in one plane, is known as unpolarized waves, okay? And then if I want, I can polarize them vertically or horizontally, okay? So polarized waves are waves in which the vibrations occur in a single plane. Transverse waves are plane polarized. Longitudinal waves, I cannot polarize them, okay? Sorry, I'm a little bit ill. Alright, this is another example of polarization. So here, this wave is polarized up and down, and this wave is polarized sideways, but still at 90 degrees is moving 90 degrees, so is a transverse wave moving 90 degrees from the direction of the wave, the vibrations, okay? And then imagine then here I have the plane, so they were allowed to move 90 degrees up and down, and here you don't have any other wave. That's because maybe the polarization would be 90 degrees from that one, and in this one would be the opposite. So for example, here I would allow the waves to move sideways. Here I could have a polarization that is only 90 degrees up, so no waves comes out of the other end, okay? And here it is all in diagram in case you want to write this down. So I have unpolarized waves, I put a slit, I get the polarized only in that direction, in this case is vertically. And then if I have a horizontal polarization and I try to do it, because I only have vertical polarized waves, no waves are going to go through the second slit. And here again another example, unpolarized light passes through a Polaroid, so a slit, a filter that only allows polarized light going vertically, and then I have a second Polaroid that is at right angles to the first one. Again, only waves moving up and down could go through. There are no waves moving up and down, so no light gets through the second Polaroid. And this is very similar to how polarized sunglasses work. So when you get the light is unpolarized, sorry, I have an issue saying this word. So from the sun or light bulb is unpolarized. This light only gets directed and into the glasses, and there is the Polaroids have a Polaroid, as you can see, so only allow light in one direction. So you can reduce a little bit of the intensity or the glare, but the best way to reduce it is when it hits a surface, it gets reflected into one plane, in this case horizontal plane by reflection, and then when it gets to the sunglasses again only emits or sends vertically polarized light, so the glare is greatly reduced, okay? So Polaroid sunglasses are going to help you a lot in terms of waves being reflected in the water, in the surface, not so much if you look directly into the light, but that is it. That's how they work, is by polarizing the light waves and therefore reducing the intensity of the light waves. And that is it for today about waves and vibration. So that's the first of several lessons at A level of waves. And again, always check the GCSE. I'll always put the link. Check the GCSE so you know the basics. Up to my next video. Be happy and healthy. Bye.